Millions of years ago, when the world was a lifeless place, volcanoes spit hot lava ash into the surrounding oceans, and as it slowly reacted with the salty seawater, something truly ingenious formed. Something that fundamentally changed the way we live. The sieve.
Well, to be honest, it didn't look exactly like this. It looked more like a totally boring stone, and this stone was also completely useless for things you would normally do with a sieve. For instance, to separate noodles from hot water or to use it for cooking in general. So you might justifiably ask, well, what is it good for? And I tell you, with this stone, you could sieve the smallest particles our world is made of, namely atoms. Depending on the composition of the lava ash that gushed out of the oceans and landed in the seawater, many, many different types of these atom sieve stones were formed. But as the word atom sieve stone is way too intuitive and self-explaining for the scientific community, they just decided to call them zeolites. Yep. That's what they did, and this word is very, very important for my slam. So please try to plant it in your brains. Best we do it like in school and repeat it a few times. Zeolites. Very good. Zeolites. Perfect. So, how does such a zeolite work? If you zoom very, very strongly into this zeolite, then you will see small holes, very similar to the holes of a normal kitchen sieve as well. But the zeolite doesn't work as straightforward as a normal kitchen sieve because it has a very interesting additional property, almost something like a superpower, if you want to. The zeolite can not only separate the particles by means of their size, but also by means of their characteristic properties. What does that mean? Let's take two particles here. Then you can see one is red and the other one is green. If we now have a zeolite that is totally impressed by the red particle, because, for instance, this particle contains an electric charge, then once the particle comes too close to the zeolite will grab it and never let it go anymore, hopefully. Now, the green particle, well, contains no electric charge and affects the zeolite only peripherally, as we say in Austria. Now, you should not think the same way of zeolites as zeolites think of the green particles because they are very useful in our everyday lives. I just composed a few examples for you. So, from car catalysts to dishwasher taps, water purification, CO2 filters, the grains in cat toilets, and even to purification of nuclear waste, everywhere where atoms and molecules need to be sieved, zeolites play a very important role. In the laboratory, we are able to synthesize over 200 different zeolites, each with characteristic filter properties. Therefore, we just take the same substances that are in the lava ash and in a first step mix them up with water. What we then get is a quite boring, transparent liquid. And if we leave this liquid at room temperature, then it will stay the same boring and transparent liquid. But if we add heat to this mixture, for instance, put it into a burning hot volcano, then the magic happens. After a short time, the boring transparent liquid transforms into a beautiful zeolite. Now, and exactly this magic is the field of research our group from Linz and Leuven in Belgium is working on. On the one hand, we want to understand how the formation of this nicely structured material is going on, and on the other hand, we want to specifically influence the zeolite in order to do something that we call rational zeolite design, which means designing zeolites just the way we want them to be and we want them to behave. And there's a very interesting method to do this, which makes use of acoustic signals. Because if we treat the zeolite just in the right way with acoustic waves, then it can be that the atoms and molecules arrange themselves differently as they would do without the sound waves. The result then could be, for example, a different zeolite as we would expect, a faster growing zeolite, or probably even a new yet undiscovered zeolite. And exactly this experiment, dear ladies and gentlemen, I want to conduct with you live on stage tonight. Therefore, we just repeat the cooking process of before and see how the zeolite reacts when we additionally treat him with sound waves. Okay, 1, 2, 3, 4. Ori, 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 ori. We need more energy. Please help me just a little bit. 1, 2, 3, 4. Ori, 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 It's pale red on the surface. And it's brown in the middle. And it's full of alcohol. I call this one the Austrian. Thank you very much.